Hello everybody, my name is Walter and this is episode 16 of my Redstone Circuits Series. In this episode I want to talk about item transport and storage. This will also include item distribution and filtering, by the way. Now this episode is mostly meant to give you an overview over the options you have and that I think are worth knowing about, but it will by far not be complete because the options are pretty much endless here. This is just to give you an overview over what I think you should know about when you are talking about transporting and storing items. And that should be enough of a prologue, so let's get straight to this episode. So first of all, as mentioned in the beginning, this episode is only about the item transportation and the item storage. The actual generation of those items will be covered in a later episode when I get to the subject of farming. Now with that out of the way, let's talk about item transportation through inventory. Now, item transportation through inventory can be done in several ways, but one of the most common ways is using hopper chains. You just put a chain of hoppers which can go horizontal or downwards, and if you put items into, for example, a chest in one end, those will be transported through this chain and will, for example, be pushed into this chest right here. So this is a rather straightforward and simple way to transport items. Using redstone power you can lock hoppers, so you can also control the transportation itself a bit. And you can also use it to introduce some delay. Usually it's a bit of annoyance, but sometimes you need those 4 ticks per hopper of delay. Now another thing I should mention here is if you want to detect the flow of items through those hoppers here, you have to be careful how you do this, because come on, let me get this, and now let me put this in here. You can see of those 2 hoppers, or of those 2 comparators, only one is activating, although the items are flowing through both hoppers they are looking at. The problem with that is this hopper here is not pushing the items into the next hopper, instead the items are being pulled from the next hopper, or by the next hopper. This means the items aren't long enough inside of those hoppers here to actually trigger the comparator. This hopper down here, on the other hand, has to push the items, so that's where the 4 ticks come into play, and this is long enough for the comparator to detect this. So when you want to make sure that you can actually detect the items flowing through, you have to make sure that you are not detecting or trying to detect from a hopper that has its items being pulled out of it. Just one thing to be aware of here. Now another way to transport items is using droppers. This is very similar to the hopper, but now you can also go upwards. You will see an example in a few moments. And you can also play around with the timings, because now this is not an automatic process that is running on an internal timer of the hopper, but instead now it needs redstone power. So for example here we have 4 droppers. One has a couple items in there, and the last is just running into empty space in this case. And then we have this line of repeaters here. Now the repeaters can actually trigger the droppers since they are using quasi-connectivity, and also at the same time the repeaters are also producing block updates, so the dropper actually detects that. And the result is that in this case, just after 3 redstone ticks, you get your item being spit out at the end here. So this can be adjusted. You can also make the whole thing as slow as a hopper chain, essentially, as you can see here. So you can play around with the timing if you need. You can even make this an instant transportation of items, with, of course, a certain reset time. How to do this you can see in the video by Maizuma Games, which is linked in the description. Just know that it is possible to do this. Now there is one disadvantage of this, and this is that it is noisy if the droppers don't actually have an item to push around. So if they are empty, they make a lot of noise. So that's the dropper chain. Now if you have them going straight up, it's also sometimes called a Dropper-vator or dropper elevator. And depending on how you build this, this can be completely silent and lossless. Now silent means that as you can imagine it only runs if there are items to be transported, and it runs in a fashion that avoids any unnecessary noise. And the lossless means that if you put a full stack of items inside of the input, you will get the same amount of items out at the end. And there will no items be stuck inside of the dropper elevator itself. This design is, as far as I know, also by Maizuma Games. Link for that also in the description. The whole thing works pretty straightforward. We have our input, which is basically this hopper here, which runs into the first dropper. And as long as there are items inside of the hopper, this clock here is running and basically activating the droppers in a chain reaction that goes upwards and basically just pushes the items up one by one. Now, a rather interesting thing to know about droppers here is that if you have two droppers on top of each other and you power them in a certain way, you can actually have both droppers activating at the same time and both moving the same item up twice. So you don't need to wait one tick for the first dropper to activate and then the next tick you activate the next dropper. You can actually activate both at the same time, and due to the update order, they will also push the items up twice. One thing to be aware of here. Another way you can use to transport items is the inventory of chest and hopper minecarts. Now, if you want to do that, you will need some kind of minecart loading system and a minecart unloading system. The minecart loading system is pretty straightforward. We have a hopper, for example, running into this, in this case, chest minecart, which stands on top of a detector rail. Now, the detector rail in combination with this comparator here detects how full the inventory of the minecart is. In this setup here, the reference signal strength is 15, and this means this system here will only activate when the inventory is completely filled up. If that is the case, the comparator turns on, turns off the torch, then this piston here retracts and the chest minecart will start running along this rail here to wherever the unloading station would be. Now in this case this is a very short distance and you would likely go instead with a hopper or dropper system, but if you have a very long distance, this might actually be a more efficient way to go about things. So let's show this in action. I have already somewhat pre-filled in this minecart, and all that's missing is filling in this slot here. And once that happens, you can see the system detects that, and now the minecart is in our unloading station. Now the unloading station does pretty much the same, but instead of detecting a full inventory, it detects an empty inventory. Indirectly at least. So let me wait first a moment until the system here has detected an empty inventory. And for whatever reason it... okay, the chest is full. So this system has a slight problem when it backs up. Now, how do I detect the stop or the empty inventory? Well, I can't really use a detector rail here because the detector rail would actually power the hopper and lock it from flowing items through it, or letting items flow through it. Now, a way around this would be using a hopper minecart instead, and then below that a hopper to pull the items out of that. But there is a simpler way, and that is detecting the items flowing through this hopper here. And as long as items are flowing through this hopper here, we have this piston extended. Now, as you have already seen, the main issue of that is that if you have items backlocking in the system, the whole thing will not work. It's also a bit of an advantage because you make sure that even if the system backlocks, you ensure that the minecart is only sent back when it's completely empty. So it can be an up or a downside, depending on how you look at it. So that's the system. Now let me quickly talk about a few modifications. The first is you can change the threshold for the loading station. So you can adjust how many items you want want to put into this minecart before it starts to run. You could go with more than just one minecart in this system, although then you would have some kind of loop going instead of going back and forth. You could also use a timer or maybe a system that counts how many items have flown through this hopper at the top here to adjust how many items you want to have inside of this minecart. There are many ways to adjust this. Another way to adjust the system here has to do with item flow or item flow capacity, because in the setup here you have one minecart and two stations, and it remains half of the time in one station and half of the time in the other station, not counting the time for transit. That means at most you have half the item flow, in this case one hopper, can allow for. So this has half the capacity if you compare it to a simple hopper chain. And since there are entities flying around and other things, you could also have problems with loading and unloading of chunks. Now, how can you get around this capacity? Well, I already mentioned one possibility, and that is going with a loop with more than one hopper or chest minecart in there. The other is, for example, using two hoppers running into this minecart here. For example, one from the top, one from the side. So you have a double item flow here. And then using a hopper minecart here that is standing on the edge of a block, and below that you have basically two hoppers that are pulling out items in parallel. So you would have the double item flow here and a double item flow there. And then you could use a double minecart, a double chest here and double chest there to buffer the items flows, and from there on you go with, for example, a simple hopper chain. So this is how you could increase the capacity of the system. Now, another way to greatly increase the capacity of an item transportation system, for example a minecart based one, is using shulker boxes. Because if you take a shulker box, you can place it down, fill it with items, and then break it, and the items will remain inside of the shulker box and can be transported with the shulker box and then at some point unloaded again. This makes for a very efficient way to transport a lot of items and can be completely automated using a shulker box loader and unloader. Those two designs here are by Hammeron, but there are many designs out there. So how does this work? Well, we have our loading system, which has two inputs. One for empty shulker boxes, or for the sake of this episode here, I have already pre-filled them almost completely, so there are just 16 items missing. And the second are for the actual items. And now let me quickly show you this in action. So let's fill in some items. One stack should be enough. And you can see once this shulker box here has been filled up, it gets broken by the piston up there and gets collected in this chest down here. So completely automatically you are filling those shulker boxes, and once one is completely full, it gets replaced by an empty one. So that's what the system here does. How does this work? Well, it's pretty straightforward. We have again a comparator with a reference signal strength of 15. So this will only activate if the system is completely full. And then it will trigger this observer there, which triggers the piston, and that breaks in the shulker box, which gets collected by the hopper down there. And at the same time, it will also trigger this observer here and will dispense the next one. So actually a pretty straightforward and somewhat simple design actually. Next we have the shulker box unloader. This works exactly in reverse. The input in this case are the filled shulker boxes, and the outputs are the items and the empty shulker boxes. So again, completely automated. And now let me show you this with shulker boxes that have only 16 items in there, so it goes a bit faster. So all you need to do is put in those shulker boxes here, and you will see we have a comparator that detects when this shulker box is empty, then triggers the system, which will allow for the next shulker box to be dispensed, and will also break the old shulker box. And with the setup here, the shulker boxes are collected once they have been pushed over, and the items are just pulled out by this hopper down there. And that way we get our items inside of this chest and the empty shulker boxes inside of this chest there. So that's how you can build a shulker box loader and unloader. And as you can imagine, if you combine this with a minecart system, for example, then you have a very high throughput, very high capacity, and it's only running for a very amount of time actually. Next up, let's talk about item transportation as item entity. So instead of using the inventory of a block or an entity like the minecart, we instead actually transporting the items as is, so as an item entity. Now when you're doing this, you must be aware of the 5-minute despawn counter, which gives you a hard time limit on how long you can transport an item. So when you're doing this way, make sure that the items need less than 5 minutes to actually reach their goal. One thing I want to mention here is that many of the methods I will show you here can also be applied to transporting mobs and players, although you may have to adjust for the increased height of the mobs and players. Anyway, let's start with how can you actually get an item entity and how you can get it back into a, for example, hopper-based system. Let's start with how you can get the item entity out of a hopper-based system. Well, the thing you will need is some kind of auto dropper. Now, an auto dropper is, as the name implies, just a dropper that as soon as you input items, will start to spit them out as item entities. And well, let me quickly show you this. So all you need to do is put the items in there and you can see the items are being pushed out of this dropper here. And once it is empty, it will simply stop running. Please ignore the trapdoors. They are not really part of the dropper of the auto dropper. They are for a slightly later part of this episode. Anyway, how does this work? Well, we have a comparator that detects when items are inside of the dropper. The comparator itself is part of a clock that runs through this redstone wire here into the repeater, and then we have our feedback loop, and that's the clock. And also we have a piece of redstone dust up there, which through this block here will trigger the dropper. And that's it. All you need to do beyond that is just having a hopper line running into the dropper, and that's it. That's our auto dropper. Now if you want to go in reverse, so you want to get the items back into, for example, a hopper system, you will need hoppers. Pretty straightforward. This is what they are used for. Now, a hopper can pull an item that is landing directly on top of it. It can also pull items through a block that is not full height. For example, a slab. Now here, the soul sand is a very, very special block because it appears to be a full block. It also can actually transport redstone wire, redstone power, but it's actually not a full block. If you walk on top of it, you can see there is a step. Soul sand is actually not a full block, and that means that you can actually collect items through soul sand. Just a little nice trick you should be aware of. If you have to pull items through a full block, you will need a hopper minecart, because a hopper minecart can actually pull from the top of a block on top of it. And then you can pull the items out of the hopper minecart again with a hopper. Again, pretty straightforward. A rather interesting trick you can use is you can actually teleport a block, a full block, right into the hopper minecart. So you can decrease the height of the entire system and hide the hopper minecart itself a bit. So this works exactly the same as before. So let me put this in, and you can see it has collected the item. So pretty straightforward. Although you will need, for example, a very simple zero-tick system to actually expel the block into this position here. Or you could also enclose the system here with blocks and then just normally push the block in. That would also work. So that's how you can get the item entity and how you can get it back into the system. Now let's talk about how you can actually transport the item. Now let's start with item transportation that does not really need redstone wire or redstone circuitry. The simplest one is just flowing water, because flowing water will transport items. And if you want to make this even faster, you would want to use ice below that. The quality of the ice will also have an influence on how fast the transportation is. The fastest is, as far as I know, blue ice. So you have your item flow or your water flow, and the item will be transported with it. Now at some point your water flow will stop because water only flows a certain distance. And at that point all you need to do is put, for example, a sign or an upside down slab, as I have done over there. And then you can place your next water source. And that's about it. What you should avoid is having the part with the gap in the water flow right in a corner, because then the items will get stuck in the corner and will not flow further. So that's the water flow. You can also go up and make this very fast by using soul sand at the bottom. So you have a soul sand based elevator, and then you can go further with that. So let me show you this. The item flows in here, gets pushed up and lands in the item flow or the water flow at the top and can get further. So you can do a lot just with water and also gravity if you want to go down. Now, concerning this situation where you have an item flow running into a corner, there is one thing I want to mention here, and that is if you have a block that does not fill the complete edge. So you have the ability to actually have items more or less aligned in a way that they are actually going over the edge of this block here. Now what this means is that if you have, for example, a hopper, at this edge here, you can have the hopper pulling out items from the item flow here. You can see the item has not traveled up, but instead has ended up inside of this hopper here. This can be used to have hoppers not being part of the actual water flow, but on the side of it. This is just a little nice trick I wanted to mention here. You can do this with chests, ender chests, the sea pickles and similar. So there are options you can use here. Just one thing I wanted to mention there. Anyway, let's talk about the next parts here. So the next parts are actually systems that are redstone powered, and in this case I'm going with a simple redstone clock here which activates the system. And they are all chained together, so let's actually put a few items in here and let's see what is going on. So you can see the items are getting in here, and the first thing is you can see you can use a slime based launcher system to launch them sideways. You can also launch them upwards, for example. You can combine this with ice to make the sideways launching faster and also for a greater distance, because on normal blocks they will slow down rather fast, but if you're using ice they will flow or fly quite a distance. Next up we have piston stairs. So as you can see, let me quickly refill the system. So, and let's wait just a moment until the first items start flowing. So you can see it's a pretty straightforward system. The first piston pushes the items up, then the next piston pushes them sideways, then up, sideways, up, sideways. So a pretty straightforward stairs system. The circuitry behind this is just a torch tower sideways, or torch stairs you could say, and the same for the bottom row of pistons, and then just the correct timing in between, and that's it. Pretty straightforward, pretty simple. Although it's not the fastest way, it's a way to get the items somewhat upwards. But usually in situations like this here, you would likely go with a system that uses slime block launcher. And for some reason I actually forgot to fill in the gaps here. Anyway. So, and the last example here is a piston feed tape / conveyor belt. So if you have, for example, stairs and you align the items correctly, they will land inside of the gap of the stair block and can then be pushed with the stair block around and pulled through the stair block with a hopper, for example. An alternative here would be using an alternating pattern of a full block and a slab, or an upside down slab and a normal side down slab, and or you could also use a alternating pattern of slime and honey blocks, which by the way would also work quite nicely for mobs and players. Although the slab and block variation would also work for players. But as you can see here, the variation with the stairs does not work for players. Another option would be having the stairs in alternating directions, so one in this direction, the other in this direction. That would also work for players usually. Anyway, that's, I think, enough about the system here. And that's how you can transport items quite nicely. Next up, let's talk about item distribution. Now, item distribution is something you need to think about when you have, for example, a modular system and you want to supply each module with a number of items. Now here I will first show you the simplest way, and then I'll show you two ways to get an even distribution. So this is something, for example, if you want to build a super smelter, you want to distribute your fuel evenly and you want to distribute whatever you want to smelt evenly, so you use the amount of furnaces as efficient as possible. But anyway, let's start with the simplest one. All you need for that is a row of hoppers where the items will flow through, and then you have your modules. For example, in this case I have those furnaces and they are supplied by the hopper at the back here, which pulls out the items from our main hopper chain. Now this is a first come first serve item distributor, because this hopper here will collect items out of this chain here until this furnace is full and the system starts to backlog and the hopper is also full. And only then the items will start to flow to the second system or module. And once that has filled up, the third gets a go, and then the fourth, and then the fifth, and so on. So most of the time, if you fill the system here, you have pretty much only running the first and maybe the second and maybe the third furnaces. But all later furnaces will not get any item to smelt because they are being locked into those hoppers here. Although at some point, if you just run items in there without pause for infinity, then at some point you will have a situation where basically all hoppers are backlogged until the last one and then all furnaces are running again. But this is not efficient and you have a lot of that space that is not really used efficiently. A situation like this is used quite commonly in vertical mass storage systems, but I will come to that at a later point. Now how can you get this or take this and make it an even distribution system? Well, it's pretty straightforward. You lock the hoppers at the bottom here until all hoppers at the top here have at least one item in them. And then for a moment you unlock those hoppers here so they can pull this item that is on top of them out and put it into whatever they supply. And that's exactly what I did here. So you have, in this case, 4 modules, and the default state is that all of those hoppers here are completely locked. As you can see here via this line at the back. Now when you put items in here, they will start to flow through here, and at some point you have an item inside of this hopper here. That means the comparator turns on, depowers the torch, or the torch turns off to be more precise, and that will unlock those hoppers here. So all of those hoppers here will be able to pull one item out. Now this hopper is empty again. The system here will go into its default state again and the hoppers get locked again. and then the next few items can flow through the system. And since this is fast enough, in this situation here, you get an even distribution of items here. So you can see I have run this already a few times, and you get a completely even distribution of items. At least if the number of items you put in here can be divided evenly by the number of modules you want to divide it by. So this is one way to go about this. It's a bit costly when it comes to the circuitry. You need also the space for the circuitry, and once you go beyond 15 in length or 15 modules, you will have to extend it efficiently. So there are a few possible downsides, but this is a very efficient and simple even distributor. You have also a 4-tick delay per hopper, so it is a bit slow, at least in the initial starting phase. Now another way, which is somewhat simpler, is using a chest minecart, for example, or a hopper minecart could be used instead. And all you need to do is run this minecart on top of the hoppers that are supplying the modules. So instead of our hopper chain here, we have a minecart that is running back and forth. It could also run in a circle. So let me see. Okay, I have some blocks in here, and well, let's actually empty those out. As you can see, I have already run this once. So we have 64 items here, so that would mean that once the system here is completely filled up or emptied out this hopper here or this minecart here, you would end up with 16 items inside of those chests. Now, one problem you can already see here is that the items are not distributed evenly when it comes to the time. Because this is going back and forth, you have a situation where you get 2 items in here rather fast and 2 items in here rather fast, but in the middle you get 1 item, then a short pause, then another item, then a short pause, and so on and so on. So the item distribution is not nicely automatically or somewhat robotically like in this situation here, but you have this back and forth situation. This is one possible issue if you try to activate your modules here through the items flowing into it. You also need a bit of additional space at the end, because if you have this back and forth situation, you must make sure that the minecart does not slow down on top of a hopper, because then this hopper here, or if you have had a hopper here, that hopper would be able to pull more than just 2 items out. So you would get an uneven distribution of items again. So you need a bit of additional space. And also additionally you would need some kind of item loader system, so minecart loading system as shown before, for example. So it can be a bit more complex on one side, but the actual distribution system itself is pretty simple. Next up, let's talk about item filters. Now, item filters are systems that collect only a very specific item or a certain subgroup of items out of an item stream. They are commonly used as part of locks, where items are used as the key, or if you have a farm that produces different items and you want to sort them and store them in different chests. So let's start with one of the simplest item filters and the most commonly used one, which you can see here. Now, this is an item filter that will collect gold in this chest, blocks of netherite in this chest, and whatever else comes into it in this chest here. So let's show this in action. So I have a chest that is somewhat pre-filled, and if I put it in this space here, you can see the items start to flow through this hopper, and you will see gold lands here, the netherite blocks end up there, and whatever else ends up here. Pretty straightforward, and this is actually the system I prefer because it's not only tileable but also overflow resistant. So if for whatever reason the system here starts to backlog, it will not break. There is a variation that is not overflow resistant but has a slightly different advantage. I will talk about this in a moment. But first, how does the system here work? Well, we have this hopper here, which is basically the key ingredient. This hopper here is pre-filled with 4 stacks with just 1 item. Those should be renamed items usually, or at least some item you have made sure will not be inserted into the item stream on top. Otherwise the system here will break at some point. And then in the first stack of this hopper you have whatever you want to collect or want to sort out. And you need 41 for this to work properly. Now with those 45 items in there, you are just 1 below the threshold for a signal strength of 3. So at the moment you have a signal strength of 2, and once you have an item flowing through here which you can input into this hopper here, or which can be collected by this hopper here, it will go to a signal strength of 3. That's the reason you need whatever you want to collect here, and some kind of renamed item you never input into the stream here. So once you have 3, the repeater turns on, turns off the torch, unlocks the hopper below. This hopper starts to suck 1 item after the other out. This is also the reason this hopper here needs to be going sideways and not into the hopper below. So this hopper here is never locked, but it can't push items out. It will only collect items from the item stream on top. Now this hopper here, once it unlocks, starts to pull out the items. Now let's say the item flow stops at the top. So we have at some point once more 41. Signal strength goes back to 2, locks the hopper again, and we're back to square 1. With the exception that now some items have flown through the system. We have usually 1 stuck in there, 1 stuck down here, and the rest has flown completely through and ended in this chest here. And that's how the system here works. Now there is a variation of the system that works with a signal strength edge of 1 to 2. So this is 2 to 3, and you can also work with 1 to 2. This is usually used with only the system or the item you want to sort out. And if I remember correctly, it should be this default state here. So 1 in each of those and 23 in this one here. So 27 in total. Once more, exactly below the threshold between 1 and 2. This has the advantage that you only have 27 items of whatever you want to sort inside of the system here, so you need less of those items. If you want to sort out blocks of netherite, it's usually a good idea, or it can help, because then you need less that are stuck in your filter. If you want to do this, you would have to replace this redstone wire here with a full block, so now that the edge would be once more here. Downside of that is that if this system overflows, you will get at least, even if you use filler items here, you will get at least a signal strength of 3, which would crosstalk into the neighboring items or neighboring modules. Why is that bad? Because you would unlock the hopper of the neighboring system, which would start to suck out items in here, although there are no items flowing in there. And at some point, this one here becomes empty, and it no longer works as a filter, so this would break the neighboring modules. So this is something you can do, but this is a variation I would only use if I am absolutely sure that I will never have this part of the system backlocking. Very important to know here. Now another thing I want to mention is that you can also replace this line of hoppers at the top with a rail and then have your minecart running back and forth. Just keep in mind that if you have a lot of similar items in there, the minecart will have to run basically back and forth once for each item you want to sort. So this one here sorts them always in the same sequence. A minecart that is running back and forth may do so for some time. Next, you can also sort items concerning their stack size. So this is a very simple setup that sorts them concerning the stack and non-stackable items. So basically, non-stackable item will produce a signal strength of 2, which would unlock in the bottom hopper. Stackable item will not produce a signal strength of 2, so the items will flow sideways. So as you can see, I have some stackable, non-stackable items already in there, and I also prepared an input storage here. So let's put this in here, and you can see you have at some point non-stackable items flowing in here and stackable items flowing in here. So pretty straightforward and pretty simple design. It is pretty old already. Some time ago I also made a design that could also differentiate between a stack size of 16 and 64. Link for that, if you're interested, you can find in the description. Now this next example here is a filter that uses a completely different approach, and that has to do with, or at least a somewhat different approach, and that is that you pre-fill the chest you want to collect your items in. So you can see each and every stack here has already been pre-filled with one item. This obviously only works with stackable items. Now, if you have, for example, a dropper and it tries to push an item into this chest here, it can only do this if it's a gold, chisel quartz, or netherite block. Anything else will remain in this dropper here. So you can see I will prepare this a bit, and if I already prepared this, and if I unlock it, you'll see the items start flowing in here, and at some point I have sorted them completely. Now this also works with hoppers instead of droppers, and you can see items that can't be sorted will remain inside of this dropper here. So usually you would have some kind of mechanism that makes sure that only one item gets into the dropper, or for example the hopper, and then it's pulled once, tries to sort it, and if it can't sort it, it's pulled out by another hopper and put into the whatever chest. So this is a rather simple design. The rest of it is just an auto dropper you have already seen a bit earlier in this episode here. There are ways to make this tileable and even stackable, so you have essentially a two-dimensional wall, so a wall completely made out of shulker boxes, for example, and each of them is its own sorting system. Makes for a very efficient and very interesting sorting system. If you're interested in that, I have a link in the description for a design by Gnembom. And lastly, without a real design, is you can use armor stands actually to sort out armor, weapons, and tools. So things that can actually be applied to an armor stand by a dispenser. The way to do this is first you dispense the armor stand, then you try to dispense whatever item you want to sort out. If it's dispensable or applicable to an armor stand, it will be put onto the armor stand. If not, it will be just dispensed, then collected by, for example, a hopper, and put into the whatever chest. And if it gets stuck to the armor stand, you shoot an arrow, break the armor stand, collect it, and well, basically sort out the armor stand from the armor, and then you have your different items and have the armor stand once more to be dispensed. Link for a video by Mango, I believe, can be found in the description. And that brings me to the last part of this episode, which is about storage or mass storage systems. So usually you want to store your items inside of chests, although if you're using Shulker Box loaders and unloaders, you can also make this more efficient by first storing your items inside of Shulker Boxes and then storing those in chests, since you can stack or store Shulker Boxes into more Shulker Boxes. Anyway, how can you create such a storage? Well, the simplest one you can see here. You have just a stack of chests, and behind them you have a stack of hoppers that are running into those chests. And this is a simple stacked unchained storage, vertical storage. So what this means is these chests here are independent, but it will start to fill up from the bottom up. So if you put in items, first this chest is filled up, then once it starts to backlog, this chest is filled up, then this chest, and so on. if you pull out items manually from this chest here, or for example, if you hop up below, then at that point you will start to refill it from the top. But whatever is in those chests here will not be touched by that. Whatever is in those chests here will remain in those chests. This is what I mean with unchained chests. You can also create a chained vertical mass storage. So here you can see we have basically a chain going through this entire system. Chest, hopper, running to the next chest. Hopper taking out the items, running to the next chest, and so on. So if you put items up here, they will subsequently travel through all the chests until the bottom, and then from there on it will start to backlog, part by part, or chest by chest. And if I were now to remove an item from there, or some stacks from there, it will start to refill from the top. So you have always, or once it has settled down, the full chest at the bottom and the empty chest at the top. So in this case you would have to have access to all of the chests. In this case, access to the bottom chest usually is enough. Now, what you can add to any storage system is some kind of indicator, which tells you how full the storage system is. Usually you want to do this with a chained system like this here, because, as I mentioned, that way you can make sure that if it's settled down, you have the full chest at the bottom and the empty chest at the top. With a system like this here, you could have just one item in there and it would display this chest as full. Anyway, how does this work? Well, pretty straightforward. We have comparators which are looking at the chests at different heights and then running the power either directly or indirectly into the indicators, in this case redstone lamps. There are many ways to do this. This is just a quick and dirty way I put together for this tutorial. But this is by far not the only way. So this is vertical storage. Now there is also a way to make horizontal storage, and usually you have your chests side by side, and then pretty much what I have shown you earlier with the distribution system here. This is the first come first serve storage distribution system for those chests here, and to pull out the items again we have this system of hoppers here. And that's the whole secret to this. You fill it up from the back here and you collect the items from the front there. And that's it. You could also add an indicator here, but once more, since this is an unchained system, you could end up with a situation with a only partially filled storage somewhere in the middle, and you wouldn't be able to see it unless you actually look at this system here. Although if you build it like this here, then this chest down here would actually be your output chest, or the chest you access, and this one here you could hide behind a wall, for example. Next we have mass storage using chest minecarts. Now as you can see here, you can actually stack chest minecarts on top of each other, and this is actually more efficient than just stacking single chests on top of each other, because as you can see here, 3 chest minecarts are roughly 2 blocks in height if you stack them. So about 50% more efficient space-wise. Now how can you cycle the storage? It's pretty simple. You access usually just the lowest minecart here. And if you want to cycle through, all you need to do is activate the piston at the back here, which will push just the lowest minecart here onto this rail. And then it will run, and I'm using a command in a command block to teleport it just up. And as you can see, if you use some rails here at the top, you can put it back on top of our stack here, and that way you can simply cycle through this vertical storage system. You can also combine this with some kind of loader and unloader if you want, and well, that's basically a vertical minecart storage. You can also have a somewhat horizontal or distributed minecart storage. This is something that is quite often used as a part of a bank system. So usually you have some kind of key which will only activate one of those modules here. And this basically means that you activate your module, then the minecart comes to you, and then you can fill or empty it, whatever, and then you send it back and it goes back to its original place, and then the next minecart can be selected from the system, and so on. So a pretty interesting system if it doesn't misconduct like you have just seen there. Not sure why it did that. Now it's working again. So it can be a bit finicky for whatever reason, but usually it works quite nicely. Yeah. So as I mentioned, this is quite commonly used in bank systems. A link for one bank system I designed some time ago you can find in the description. And then we have the condensed minecart item storage. Now, if you think this is just a hopper with a chest minecart and the hopper below it, then you're wrong. This is actually a hopper below it, and dozens of minecarts in between. This works because minecarts condense on top of a rail. And as long as you don't give them any kind of impulse, they will remain like this. Usually you want to encase this in some blocks, but as you can see here, it's also stable if not encased and if you don't run into it. And that means you have a lot of storage here, a lot of storage. But you can't manually access it. So this is something you would want to use for a mass storage if you just want to store one single item. There is one downside, I figure, and that is the item inflow is constant, one item every 4 ticks, but the item outflow is slower and it's not regular. So the timing involved is, or the delay is not always the same. I'm pretty sure this has to do with the order those entities here are calculated in, and well, it can wreak havoc if whatever you have built at the end of the system here actually needs them in a nice even flow. But if it's just a manual system, this is not an issue. So one way to get a lot of storage. Another downside is you have now quite a lot of entities that are colliding with each other, so it can produce some lag. And as mentioned before, all of those storage systems here you can also combine with Shulker boxes to even increase the capacity quite a bit more, by a factor of 27. And the last storage is a rather interesting storage, and that's the Ender Pearl Stasis chamber. So this is also sometimes called the teleport button, and it works pretty simple. You have a row or a column of water with soul sand at the bottom, and it should be at least 6 or 7 high. And if you were to put in a Ender Pearl, you can see it starts to float and remains there. And as long as nothing gets in contact with that, nothing will change. But the moment something gets in contact with that, for example, if I close this trapdoor here, whoever put in an Ender Pearl in this whole thing, this can also be done by several people in parallel, whoever has an Ender Pearl waiting here will be teleported to the space here immediately. So this is something you can use for a secret entrance or to make sure that you can teleport back after a certain amount of time, whatever. So there are many options you have, and it's a quite interesting concept. And with that we have reached the end of this episode about item transportation and storage. I hope you enjoyed this little episode, and well, see ya!